Hello everyone, welcome. We solve for the value of x in this exponential equation given as 5 raised to the power 2x plus 1 minus 3 into the bracket 5 raised to the power x plus 1 plus 10 is equal to 0. So what is the value of x? Solution, we have 5 raised to the power 2x plus 1 minus 3, 5 raised to the power x plus 1 plus 10, this is equal to 0. Okay, so the first thing is to apply the that is indices identity that state that a raised to the power n plus m, this is equal to a raised to the power n multiplied by a raised to the power m. So we apply this identity so that we will have 5 raised to the power 2x multiplied by 5 raised to the power 1 minus 3. Here we'll have 5 raised to the power x multiplied by 5 raised to the power 1, close the bracket, plus 10, this is equal to 0. Okay, and then we proceed and say let 5 raised to the power x be k. Okay, we substitute the 5 raised to the power x with k. We're going now to have 5k squared minus, this is 5 times k times 3, so we'll have 5k, we'll have 3 multiplied by 5k plus 10, this is equal to 0. Okay, so that we'll have 5k squared minus 15k plus 10, this is equal to 0. Okay, so to solve for the value of k, remember here we have our a, this is a quadratic equation. Since this is a quadratic equation whereby our a is equal to 5, our b is equal to minus 15, and our c is equal to 10. Okay, so now we apply the quadratic formula that states that minus b plus or minus the square root of b squared minus 4ac divide everything by 2a. Okay, so we substitute so that we'll have minus 15 plus or minus the square root of, this is minus 15 squared minus 4 times 5 times 10, divide everything by 2 times 5. Okay, our a is 5. Okay, so that we're going to have k is equal to minus times minus 15, this is 15 plus or minus the square root of, this is now 15 squared, this is minus 15 squared, this is 225, minus, this is 4 times 5, 20 times 10, this is 200, divide everything by 10. Okay, so that we're going to have 15 plus or minus the square root of 25 divided by 10. Okay, so you're going to have two possible values of k, which is the first one, which is 15 plus or minus, remember the square root of 25 is 5 divided by 10. So that means that the value of first value of k is 15 plus 5 divided by 10, which is equal to 20 divided by 10, which is equal to 2. That's the first value of k. Okay, while the second value of k will be given by 15 minus 5 divided by 10, and 15 minus 5 is 10 divided by 10. Okay. So we have two possible values of k. The first one is 2, or k is equal to 0. Okay, so we're now given that the value of k is equal to 2 or k is equal to 1, and if you recall, we concentrate 5 raised to the power x bk. Okay, so we substitute with these two possible values of k. So the first value of k is 2, so we have 5 raised to power x is equal to 2. Okay, so for x we introduce the natural logarithm, so that we'll have log 5 raised to power x, this is equal to log 2. Okay, so introducing a logarithm identity that states that log e raised to power p, this can be expressed as p log a. Okay, so we apply this identity so that we'll have x log 5, this is equal to log 2. We define both sides by log 5 and divide the other side by log 5, so that the value of x is equal to 0.431. That's the first value of x. Now the second value of x, we have k is equal to 1. Okay, now then we'll have 5 raised to power x is equal to k, which is equal to 1. Okay, so 5 raised to power x is equal to 1. Okay, so we introduce a very interesting identity, that is a indices identity, that states that if you have a raised to power 0, this is equal to 1. Okay, so we can write this 1 in the form of with a base of 5, so that we'll have 5 raised to power x, this is equal to 5 raised to power 0. And since the bases are common, we are saying that if you have a raised to power n, this is equal to a raised to power m, and since the bases are common, we just consider the powers, so that means that n is equal to m. Okay, so we apply this identity. Okay, so we have 5 raised to power x, this is equal to 5 raised to power 0, and since the bases are common, that means that x is equal to 0. Okay, so we can verify if this is true, given that the value of x is equal to 0. Let's verify. Now we have our exponential equation as 5 raised to power 2x plus 1 minus 3 into the bracket 5 raised to power x plus 1 close the bracket plus 10. This is supposed to give us 0. Okay, so we just substitute, so that we'll have 5 raised to power 2 multiplied by x, which is equal to 0 plus 1 minus 3. This is 5 raised to power 0 plus 1 plus 10. This is supposed to give us 0. Okay, so if you say 2 times 0, you'll have 0 plus 1. You are going to have 5 raised to power 1 minus 3 into the bracket. This is 5 raised to power 0 plus 1. This is again 5 raised to power 1 plus 10. This is supposed to give us 0. So it's true that if you check 5 raised to power 1, this is 5 minus 5 times 3, which is 15, plus 10. If you say 5 minus 15, this is supposed to give us 5 minus 15, this is minus 10, plus 10, this is equal to 0. Okay, so it's true that whatever is in the left hand side should give us should be equal to the right hand side. So we can see 0 is equal to 0. So that means that the value of x is either 0 or x is equal to 0.431. Okay, and that is proven as we have calculated. Thank you for watching, guys, and kindly subscribe.